Alright, so the moment of truth is almost here. We're about to see the usefulness of Pascal's triangle and how we're actually going to use it. So it all starts with binomial expansion. So we are talking about a binomial, so two terms, raised up to some power which we are going to call n. And so we're looking to expand this out. So suppose we look at a very simple case of n being 1. Well, there's not much to expand here. We would just have a plus b. Suppose we look at a plus b squared. So if we were to do FOIL or double distribute, whatever you want to call it, we're talking about a plus b times another a plus b. That would give us a squared plus, we would end up with 2ab, right, plus b squared. So I'm just doing double distribution, right? So you'd end up with an AB plus another AB, so that's a 2AB. So if you were to do a plus B cubed, all right, so you were to take your answer from right here and multiply that to another A plus B, what you would get is A cubed plus, you would have 3A squared B plus 3ab squared plus a b cubed. Okay, so that's what we would see if we were to expand it out, all right, and do a plus b to the third power. One more time, okay, if you were to do a plus b to the fourth power, and again, just do a whole series of distributing and combining of like terms, you would get a to the fourth plus 4a cubed b plus 6a squared b squared plus a 4ab cubed plus a b to the fourth. Hopefully you're starting to see some patterns here. Also, I want you to take a separate color like I'm about to do here, and I want you to write in what the coefficients are. Okay, so we're just going to, in the case where we already have a number, I'm just going to highlight back over it. Alright, that's a 1. So notice that these numbers here hopefully look familiar to you. Alright, these are the numbers from Pascal's triangle. Notice how this n, alright, we said earlier, equals the row number in Pascal's triangle, okay, and here it's also equal to the power of the binomial, okay. So recall how we said that, yeah, it's the row number, and we said how n plus 1 is the total number of terms. So if n is 1, there's 2 total terms. If n is 2, there's 3 total terms. If n is 3, there's 4 total terms. If n is 4, there's 5 total terms. Okay? Alright, so let's jot down some of our findings here. So the numbers in Pascal's triangle from before, notice how they are showing up as the coefficients when we expand the binomial. Okay? Also notice how the powers of a here, all right, our a is just the first term in the binomial. Notice how the powers of a, they start with n, okay? So here's a good example. All right, starts at n, which is a 3, and notice how they're going down by 1. Really, this last one here, we don't have it written, but it's really a to the 0. Okay, so notice how those are decreasing by 1. Okay, so let's jot that down. So the powers of a start with n and decrease by 1. Okay, so again here, if n is 4, we have a to the fourth, a cubed, a squared, a to the first, and there's really a to the 0, but we don't need to bother writing it. Likewise, if we were to focus in on our b powers, okay, notice how these technically start, this is the opposite, starts with a v to the 0, and then it's going up by 1. So this is the opposite pattern. So let's jot that down in writing. So the powers of quote-unquote b start at 0, and they are going to increase or go up by 1. All right? So that is a pattern that we see here throughout. And the last observation here, look at these powers and look at what they always add up to. Okay? So they, notice, will always add up to n. So if we were to add these powers, okay, they are going to add up to whatever the power is for our binomial, which is what we call n. So let's finally just jot that down. So we can capture this by saying the combined exponents in each term is going to add to n. And I said that was the last thing to write down, but apparently I'm a big filthy liar. I want you to just jot down that n plus 1. I know I mentioned it, but I want you to make sure you write it down. N plus 1 represents the total number of terms in the expansion. Okay? I'll try not to be a filthy liar next time. Bye-bye.